Now, introduction to whole numbers, identifying and counting numbers and whole numbers, learning algebra, similar to lingo language. You start with basic vocabulary, and then add to it as you go along. Algebra uses numbers and symbols to represent words and ideas. The most basic numbers in algebra used to count objects. We call counting numbers, or another word phrase for it would be natural numbers. These are numbers that occur in nature naturally that you can count on your hand. Examples of natural numbers right there, or counting numbers. 1, 2, 3, 4, and you see the dots mean it goes on forever. Now, when you add a 0 onto it, you have another system called the system of whole numbers. So, the system of whole numbers is simply just a system. It's the set of counting numbers plus 0. In this case here, in this example here, which are whole numbers, which are counting numbers. So we look at the set that we have there. You see that 1 and 0. Counting numbers are numbers that start at 1, so 0 is not a counting numbers. So the numbers 3, 15, and 105 are considered counting numbers. So in this case here, number 1/4 and 5.2 are neither counting numbers or whole numbers. We learn about those later. Okay. Now, our number system is a place value system where each place value represents a multiple of 10. Okay. So here we have the number 374, where each place here represents a multiple of 10. We have 4 1s, we have 7 10s, and we have 3 100s. Okay. In this case here, we have 134. Okay, 138, my mistake. So we have 8 1s, we have 3 10s, and 1 100. Notice they have a block here of a 10 by 10. Give you 100. Each one of these is 10, and this is 8. Okay. So we see these blocks here. How many does it appear that we have? We have one block that says 100. So we have one block that represents 100. And we have another block that represents 100. Then we have one block of 10. Then we have one block of 5. So 100 and 100 is going to give us 200. Plus 10 plus 5. So we end up with 200 plus 10 is 210 plus 5. So we have 215. You can see that here. So we have 215. Now, this extension of the place value system, you can see all the places right here. So every 3 places here make up a period. So you have 1s, 10s, 100s. They form one period. Then we have thousands, 10,000s, 100,000s form the second period. So every 3 places going up form a period. Ones, thousands, millions, billions, trillions. So you look at this number here. We see the number 5 million. Okay. You see number 5, digit 5, it's a symbol. You see that's in a millions place. The number 2 is in a 100,000s place. The number 9 is in the tens place. and the digit 4 is in the fourth place. Okay. Now they want us to break this one down. So they want us to find a place value for each place. So looking at this here, we see that the 7 is in the thousandths place. The 0 is in the 10,000ths place. The tens, this 1 here is in the tens place. And the 6 is in the 10 millionths place. And the 3 is in a millionth place. So that, now, when we name whole numbers, we name them after the periods. So if we have 37,510,248, so in this case, see, the numbers are named after the period. So you see that 37 is going to be in the millions place. 519 is in what period? The thousands place. And the 248 is in the ones place. So we break this down. We see that 710 is in the ones place. Okay. The 98 is in the thousandths place, the thousandths period. 710 is in the 98 is in the thousandths period. So you have 98,432,165,000,000 and 8 trillion. So when you're reading it out, you read it out as according to a period the digits fall in. You can see that here. When you write this out, you write it out according to whatever period it falls in. The 8 is in the trillions period. 165 is in the billions period. 432 is in the millions period. Thousands is in the thousands period. And 710 is in the ones period. Now they want to take us to take this rather than words. So we write it in words according to whatever period it happens to fall into. So we have 327,577,529. So when you put that together, we see 327,577,529. Notice there's no ands here. Now they're going back together where they're giving us the phrases and they want numbers this time. So we have 53, that's going to be in the millions place. So in the thousands place we have 104. What's that? 401,000 there in the thousands period. And 142. 742. In the ones period. So they want, in this one here, a state budget is in 77 billion right out. What would that be? So that 77 could be in the billions period. We don't have anything else, so we don't show anything else here. So that's how it would look. Zeros in the millions, zeros in the thousands, and 0 ones. So it's 77 billion. Now we're going to look at the idea of rounding numbers. Okay. So using a number line can help you visualize the rounding process. Look at a number line in the figure. So you want to round the number 76 to the nearest 10. Is 76 closer to 70 or 80 on the number line? So there's 76. It's closer to 80. So the nearest 10 would be 80. Okay, so here we have 72. We want to round that to the nearest 10. The nearest 10 would be 70. And here we have another one, 75. So it could go either way. So you have a rule set for it. If it's 5 or greater, you round up. So your nearest 10 would be 80. Okay. So when we're looking around 76 to the nearest 10, we have 76 here. Okay. So this is a check digit here to tell us whether we round up or down. We look at the tens place. So you see that it's 5 or greater, so we round up. Now this means approximately. So 76 will round to 80. So if we look at number 72, there's our check digit, and we see that 2 is less than 5. So the nearest 10 in this case is going to round to 70. So if we look at 75, and that's our check digit, when we round up, it's 5 or greater, so the nearest 10 would be 80. So now they want us to look at round to the nearest 100. So we have 23,658. And they want us to round to the nearest 100. So that's the ones, tens, hundreds. So that's our hundreds place. So we check to see what's going on here. So is it 5 or greater? Yes, it is. So the nearest 100 is going to be 23,000. Then it's going to round up to the nearest 100, 700. Okay, so let's look at another one. So here we have 3,978, and they want us to round to the nearest 100. So we look to see what's going on here. So you see that check digit there, it's 5 or greater, so the nearest 100 is going to change. Round that up to 9. So in this case here, the nearest 100 is going to be 4,000. Now they want us to do more with that. Round to the nearest 100. Round to the nearest 1,000 here. So the demo we have. Round to the nearest 1,000, so that's our thousands place. So if it's 5 or greater, we round up or round down. So in this case, it's less than 5. So the nearest 1,000 is going to be 147,000. Next one is taking around 29,000. 504. So they want us to run us to the nearest thousands place. So that's our thousands place there. So we check to see what's going on here. So if it's 5 or greater, so we round this thousands up. So the nearest thousand is a 9. So the nearest thousand is going to be 30,000. And that's the end of section 1.1.